All right, so we're going to go over just an additional problem of this standard normal curve, because I feel like it's kind of one of those things where, um, if it's tough because you're like, well, when do I use it? When do I not use it? So anyway, so for this example, I've got that a study finds that the average score of the Algebra 2.2 final exam were normally distributed with a mean of 72%. And a standard deviation of 4%. And a test grade is randomly chosen. So, what I always like to do, regardless of the situation, is draw a picture to represent this, okay? So we know it's normally distributed, so we can use a bell curve to talk about the shape of that, okay? So, excuse my inability to draw lines today. So we're here, okay? And I know that the mean, they told me that, so the average, if you will, is 72%, and a standard deviation of 4%. So a 4% upward would be a 76, and then it would be an 80, and then it would be 84, and then backwards would be 68, and then 64, and then 60. Okay? So that's just in general the bell curve that we've got going on there. So what I'm going to ask now is that what is the probability that the test grade you chose is 77% or less? Okay, so 77 falls right about here. Okay, on your picture. And we talked about earlier in 11.1 how if it falls directly on right on one of the standard deviations, then you can just use that idea of, well, it's broken down where 34% are here, and then that picture was shown. The issue with this one is that it doesn't fall right on one of those lines, and so we have to use the standard normal table. So what we're basically going to do is normalize it or standardize it, and then look at the table that we're given. So that's why we have to use this method instead of the other one. So we use what's called a z-score, and the formula is for that to take the x value minus the mean and divide it by the standard deviation. Okay, and the value we want is 77. We subtract the average, and we divide by the standard deviation. Okay, and 77 minus 72 is 5 over 4. And so when we do that in our calculator, 5 over 4 as a decimal is 1.25. Okay, so we just found the z-score, if you will. Okay, and so the z-score says, okay, the probability that the test grade we choose is that or less is the probability that our z-score is that number or less. Okay, so we're looking for the probability that our z-score is less than or equal to 1.5. And as luck would have it, we have a table down here. And remember, this table only talks about scores being less than or equal to, but luckily that's what we have here. We have a less than or equal to situation. So we look for 1. And then 0.25. Okay, so now what we have to do is we have to say, well, because our table only talks about the 10th position, this actually rounds to 1.3. Okay, so that's the number we're going to look for. So we go to 1, and then we go to 0.3, and that's the number that we need. So 0.9032, which if we move that to be a percentage, because that's just a little bit easier to understand, we have 90.32%. So what that means is that if we choose a test grade at random, there's a 90.32% chance that grade is going to be 77% or less, which would make sense because if you think about the probability being the area under the curve, it's a lot of this curve up there, right? And the whole area under is 1. So the fact that we're choosing here or less, that would make sense to be 90% of our whole area. Okay, so then we got to things like B, and B asks, what's the probability that the test grade you chose is a passing grade? Okay, well, a passing grade is anything as long as your grade is above a 60, right? So I'm basically asking you, what's the probability that your grade is larger than 60? So let's find this z-score. So z equals 60 minus the average of 72 divided by the standard deviation of 4. And that's 12 divided by 4, which is exactly 3. Okay? So we want the probability that our z-score is now greater than 3. And now we've kind of run into a bit of a roadblock because our table only talks about things that are less than or equal to and not greater than. Okay? So what we have to say is, okay, well, the probability that z is greater than 3 is equal to 1 minus the probability that z is less than or equal to 3, right? If there's a 10% chance that it's going to rain, there's a 90% chance that it won't. So whatever our probability is on the other side of it, right, whatever it's not, you subtract that from 1, okay? So now we've got 1 minus, and the probability that z is less than or equal to 3 is right here, right? So that is 1 minus 0.9987. Okay. Oh, wait. I've made a mistake. Let's catch ourselves. Here's my mistake. 60 minus 72 is negative 12, which makes this a negative 3, which makes this a negative 3, which makes this a negative 3. So the number we look for, luckily that mistake only drove me just a little bit crazy. That puts us here, negative 3, right up here. Okay, so 1 minus 0.0013. And so when we plug that into the calculator, 1 minus 0.0013, which is 0.9987, which means that there's a 99.87% chance that the test we choose is a passing grade, which is really good. That's awesome. That means hardly anybody failed, which is great. Okay. It's always those pesky little negatives that get me. All right. So here we go. What is the probability that the grade you chose was between a 70 and a 90? Okay, so I'm going to go back to my picture. I want to know that the probability is in between here and, let's see, another one would have been 88 and like here. So I'm basically asking you for this whole area here, right? I want to go between those two things. So what we're going to do is we're going to find the z-score for each one of these boundaries, and then we're going to talk about what to do with them. So the z-score for the first one would be 70 minus 72 over 4, which is equal to negative 2 over 4, which is equal to negative 0.5. And the z-score for the second boundary would be 90 minus 72, okay, just so that I don't make another silly mistake here, divided by 4. That's 18 divided by 4, which is equal to 4.5, which is a problem because my table doesn't go that large. Hey, what if we changed this to 80? Sorry about that. 80%. So then this would make it 80 minus 72, which would be 8 over 4, and 8 divided by 4 is exactly 2. Okay, that works better. Okay, so what this means, okay, if we use this z-score, that's the probability that we're less than, so I'm gonna use a color so that you can kind of see. So if we found this z-score here, that's the probability that we're less than 70. Okay, so that's this right here, which is not what we want. Okay, so that's that probability. Now the probability that we just found, like with this z-score, that would be the probability of everything under 80, which is right here. All of that. Okay? And so what we want if our score is 80 is we want this section right there, right? We don't want any of that because that's less than 70. We don't want less than 70. We want it between 70 and 80. So what we're going to do is we're going to take this z-score and subtract that one. Okay, well, the probabilities of them anyway. So the probability that our z-score is less than or equal to negative 0.5, so negative 0.5 is 0.3085, and the probability that we're at positive 2 is 0.9772. And so then we're going to subtract them. 0.3085. So you get 0.9772 minus 0.3085. And you get 0.6687, which means there's a 66.87% chance that a score that we randomly choose is in between 70 and 80%. Okay? Hopefully this helps, or at least gives you a better idea of what your questions are so that you can go to your teacher and ask those more specific questions. So let us know if you need anything else.